Hello and welcome for some tough integration. The integral you're seeing in there, it has a pattern, some kind of like a technique. And I will have probably another couple of them that are based on the same idea. And I will try to upload them, or actually do them first and then upload them very, very soon. So you can actually see some of these techniques. Okay, let's get on with it. It's indefinite, although I have seen this with limits as well. E to the minus x bracket x squared plus 3x plus 3 close bracket sine x over x plus 1 all cubed. I mean, what should be going through our mind when we say something like that? Well, obviously, start crying is kind of like a common emotion, but the next thing is to notice that all these kind of quantities, they will involve some kind of integration by parts eventually. And before I actually tell you what kind of patterns are involved in there, I'm going to take this algebraic part and I'm going to split into partial fractions. I hope it doesn't take too long to do so. So at the moment, by partial fractions, I can say, well, x squared plus 3x plus 3 over x plus 1 all cubed will be identical to something over that plus something all to the power of 2 plus something to the power of 1. You probably would do it by equating coefficients, this particular one. So this one will be just the OA, bx plus 1 plus c bracket, we're timesing by x plus 1 all squared. And if we look carefully, without writing much, c will be equal to 1 by looking at the x squared. The x bits will be bx plus 2. Cx is equal to 3, which means this is a 1. So we have, 3x in fact. B plus 2 is equal to 3, which means b will be equal to 1. And the a is the constant. So a plus b plus c will be equal to 3. These are, of course, 1s. So they're all 1s. Okay, so this didn't take too long to actually do. And what have we achieved so far? We can actually rewrite this integral now. 1 over x plus 1, 1 over x plus 1 all squared, plus 1 over x plus 1 all cubed, and then I have e to the minus x from there, and from there dx. And because I'm going to be doing integration by parts, it might make sense to do a little bit of differentiation of this quantity. Because of course there's going to be three, I'm going to split that into three separate integrals. That times that, that times that, that times that. And I'm going to combine. Sometimes I might be integrating that. Sometimes I might be differentiating that, as you will see. So we might as well just start preparing some of these things here. So d by dx of e to the minus sine x will give us minus e to the minus x, product rule, sine x, and then we leave the exponential alone, differentiate the cos, and if we tidy this up, we're going to have e to the minus x cos x minus sine x. And the same way, if we need to find the integral now of this quantity. How do we integrate now the e to the minus x sine x? You can do it a double integration by parts. You can use complex numbers. I'll do it by differentiation. So I'll do something similar to that. I know something which looks like that comes from differentiating an exponential and a linear combination of sines and cosines. Something like this. So left more space because I'm idiotic, I didn't. So we got a product minus e to the minus x, leave the bracket alone, and then leave the exponential alone, and then differentiate this bracket, which will give us a minus a sine x plus b cos x. And let's hope now that this will give us something sensible. So if we differentiate that, let's factorize the exponential in a positive sense. So that will give us, from this bit here, minus a sine x plus b cos x. But from this, we're going to have it in reverse. So we're going to have minus a cos x, that's from that bit here, minus b sine x. So that's basically what we're getting, which is e to the minus x. And we're going to get minus a minus b sine x plus b minus a cos x. So now comparing coefficients, we want to end up with, when we differentiate that, just with e to the minus x sine x. So that means b minus a, the cos bits, must be equal to 0. So a must be equal to b, and this must be equal to 1. So minus a minus b must be equal to 1. Minus a is equal to 1. So a will be equal to b, and they're both going to be equal to minus a half. So I hope I didn't confuse you with that. If I confuse you, what I've just done in there, this is my style of sometimes often doing this. You could do your own method. I'm not going to be teaching you, when we're having sort of like 5-star disgusting questions, how to integrate e to the minus x sine x, do a double integration by parts, or if you're familiar with complex numbers, please use your complex numbers. So the fact of the matter is, the integral of e to the minus x sine x with respect to x, it turns out to be this minus a half. Let's put it on the outside. That's from the minus a half and minus a half, e to the minus x, and inside there we're going to have a cos x plus a sine x. And this quantity, just leave it as it is. We're going to be pressing a little bit for space for this particular integral. But all I've done so far, I've done 3 preliminaries, 3 auxiliary things. First of all, I've done the partial fractions. I got a differential of this quantity, and I got an integral of this quantity, because I'm going to be doing some integrations by parts somewhere within this question. And often with these kind of things, this is the pattern. There is not really 3 integration by parts, okay, as we see here. I did mention 1, 2, 3. It's actually only 2. Normally will be the first with that, the last with that, and hopefully this will cancel. And it doesn't really matter when you're doing this 2 integration by parts, whether on the first attempt you will differentiate that, integrate that, but if you go to the third one, you do it the other way around. So again, now we're going to be doing the integration by parts one at a time. So let's move on. So 1 over x plus 1 e to the minus x sine x dx. So at the moment, I'm just doing this integration by parts. And for this particular one, let's say we differentiate the 1 over x plus 1, and we're going to integrate this quantity. And you can see why I got these kind of things. And this is the thing, you see, when you differentiate that, you get something which looks like this. And this now will take us back to minus a half e to the minus x cos plus sine. I didn't leave enough space. I'm just copying that. So look at this integral now. I'll do it the product of that. So it's going to be minus a half. Let's put that x plus 1 at the bottom. E to the minus x, we can write it next. That's this bit here, and then we got cos x plus sine x. So I didn't have room to write it there. Minus the integral of this diagonal is going to go plus, and this diagonal will go to 1 over x plus 1 all squared, add the exponential, and we got more mess, sine x plus cos x. And you should notice that bit here. If you look, the 1 over x squared e to the minus x sine x, which appears in just this bit here. Okay, dx. Do I do anything else with this? I guess I could expand it, but for the time being, let's leave it as it is. So I'm going to write it. I hope I don't run out of space. This is just a long integral. And I said, you know what? This times that. Let's put the e to the minus x on the top up there. Sine x dx. It turned out to be a minus e to the minus x, to bracket, very easy to miss things here, cos x plus sine x minus I missed a half in here, by the way. Sorry about that when I've done this product. I'm notorious for mistakes, so please watch me. I used to miss, for example, a power. I put that on the top, and we got sine x plus cos x dx. So this is now integration by parts for this quantity here. I've got very little space, and now we're going to do, as I just explained the plan with this, I'm hoping for the middle bit to cancel. So now, rather than going into this, I'm going to the one that has the cube. So this is now that times that, but now my integration by parts, the first time I differentiated that, if I differentiate, of course, I'm going to go to the 4 at the bottom. So I want to integrate this now, and I want to differentiate this quantity. And of course, this I differentiated, I've got it ready. It's going to be e to the minus x, I'm reading from there, cos x minus sine x, and integrating, what am I integrating? I'm integrating this mess. That's going to go minus 1 over x plus 1 all squared, and that will give me also, I will need half for this one at the front. Very annoying. I'll write it like this. So, product of that, so that's going to be minus 2 x plus 1 all squared, and then I'm going to put the exponential on the top, e to the minus x, and lose this 1. And then we got just the sine of x minus the integral of this diagonal. And the diagonal will go plus for this one because we go minus. And let's write the half like we did for that. Yeah, why not? That's the half, better than forgetting all about it. X plus 1 all squared. The exponential, I'm going to write it on the top. Come on. E to the minus x. And then we've got, of course, cos x. You got to excuse me, my hand is shaking an awful lot. Is some of the medication that I'm taking is so frustrating, so annoying. I'm very angry actually at times. It's like having a fit, a heart attack and masturbating at the same time. It feels like it at the moment, so I do apologize. So this is the integration of that times that. So let's write it on the side here, and let's see what happens now with this integral. A lot of us would have given up. The first time I saw this integral, I thought, it must have come on, go away. I'm not doing anything with this. I refuse to even touch it, but it does have some theoretical value. So hopefully no mistake in there. Common mistakes in this kind of thing is to miss these factors of 2 halves. Signs can go wrong on this one, and then things don't quite cancel the way they're meant to. So that is, wow, I was copying that line. Wow. No, I'm copying this line. Minus e to the minus x2. You see, I'm talking and I'm going to say stupid things and I'm going to make a mistake. And then we got the plus a half integral e to the minus x, and then we got cos x minus sin x dx. Okay, so far so good. We're almost at the end. I don't know if we have enough room now to kind of like put everything in a sensible way to see it. Recap what we've done so far. Split that into partial fractions. We've got some results ready because we're going to do integration by parts, but the integration by parts are not for all three quantities, but only for two. That times that and that times that. Hopefully this times this will be left as it is and it will cancel. So now I'm returning to the main line, and this is what we got so far. Minus a half e to the minus x cos x minus a half e to the minus x. No, probably not a good idea too. Hopefully we can see it. I won't have space, unfortunately. I was going to expand it all, but probably going to run out of space. So I'm copying this line. Do I really need to copy it? Let's copy it, and we'll make room somehow down there. 2 x plus 1. Sorry, it will make the video a little bit long, but it'd be easier to see what's going on, I guess. X plus 1 all squared, and then we've got sin x plus cos x dx. Underneath, it's not another equal, I'm just adding now. So we got minus e to the minus x. This is not quite the same because, of course, it has this squared and it only has a sine of x, plus a half. And here we're missing something. Oh God, what was that? That was, I didn't copy it. I think it was x plus 1 or like squared or cubed. I think it was, try to picture, yeah, it will be squared. Okay, I do apologize. If you turn the video back a little bit, it's me talking, and this is the story of my life. So that's that bit there. And then we got a cos x minus sin x. I hope I haven't made any other mistakes, because now that was kind of like I can picture the integration by parts, but anything else, forget it. And now I'm rubbing off even more stuff, and if it doesn't work, it's okay. I'm gonna go and have something to eat and forget about this integral. He beat me. And we got, of course, let's not forget, this was still there, and this is just an integral. We haven't integrated it. There's no half, but it is the integral of 1 over x plus 1 all squared. So that's the middle bit which we didn't touch, and e to the minus x with a sine of x, I believe, dx. And let's see what happens in there. All of these integrals, first of all, let us notice they have e to the minus x, x plus 1 all squared at the denominator. It's just different bits of sines and cosines. So if we account just for the sines and the coses, try to follow what I'm doing, we're going to have minus a half sine from there, minus a half cos from there. We have plus half cos minus a half sine, and then of course we got a whole sine. Goodbye. All of these integrals annihilate each other. They will just cancel each other out. I'm going to use my orange pen and say bye-bye. Finished. Okay, so we are left now with the integral, really. All we need to do is just write it a little bit better. So it's just that plus that equal, factorize possibly a minus a half exponential the x plus 1 to its lowest power is to the minus 2 when we write it on the top. So, looking at this quantity here, this is just everything that I've got in there, except, of course, the sine of x. And when I look at this, I'm going to have an x plus 1. Wait a second. Yeah, x plus 1. And then I have, of course, a cos x plus sine x. If you want to put a few extra lines for that, it's not a problem. I'm sure you should be able to see this. And from this quantity here, I've got sine x plus another sine x from this quantity, from this bracket, plus an x sine x. So I've got a total of, let's put the e to the minus x. And then I've got x plus 2, lots of sine x. Just double checking that. Sine x plus sine x is 2 sine x, and then x sine x. And from the cos, this is very easy. X plus 1 times cos. So x plus 1 times the cos of x, square bracket. Let's check that we haven't missed anything. The exponential is there. We need to put that on the denominator, squared. We got a 2. That's from the half. And of course, we've got a minus, which we can stick at the front. And of course, we finished all the integrations. And let's not forget the plus c at the very end. Okay, I don't know how you found this integral. I just want to finish this video because it's quite long. But integrals like that, I have, as I said in my resources, maybe about 2 or 3, is something that has discussing integration by parts. Normally there'll be 3 items like you saw in there, and you do the integration by parts of 2, and it turns out that the third one cancels every time. Something unexpected and perhaps rather beautiful at the end, which allows the integral to be done. Okay, I'm going to be signing out. I'll see you real soon. Bye for now.